So in this video we're going to go over a technique for sequence dating using matrix transposes. So here's the basic idea. It comes from archaeology, and the assumption that archaeologists make is that if you have graves, so say grave 1, grave 2, grave 3, that are in the same region, if they were dug and someone was buried in them around the same point in time, they should have similar types of artifacts in them. So if grave 1 and grave 2 were within a few years of each other, if artifact 1 is in grave 1, it has a high chance of showing up in grave 2. If artifact 2, or a pottery shard for example, shows up in grave 1, there's a high likelihood it might show up in grave 2 as well. Whereas if grave 3 is a lot older or younger than either of graves 1 or 2, it may have pottery types or artifact type 3 that didn't show up in the previous grave, because artifacts and pottery types and styles change over time. So in sequence dating, what archaeologists do is use the numbers of shared pottery types or artifact types to try to sequence or identify the temporal sequence in which a series of graves were dug. And the way that they do it is they encode the grave and pottery or artifact information into a matrix. So in this matrix here, each row represents a different grave that was dug up by archaeologists. So this is grave 1, grave 2, grave 3, and grave 4. And the columns represent the types of pottery that were found in the grave. So we have pottery type 1, pottery type 2, pottery type 3. So what we do is, if grave 1 has pottery type 3, we put a 1 there, but if grave 1 doesn't have pottery type 3, we put a 0. So row 1 says that none of pottery type 1 were found in grave 1. None of pottery type 2 were found in grave 1, but pottery type 3 did occur in grave 1. The second row says that pottery type 1, because this number's a 1, was found in grave 2. Pottery type 2, because this is a 1, was found in grave 2. Pottery type 3, because this is a 0, wasn't found in grave 3. And then you would interpret the other two rows the same way. If there's a 1, then the type of pottery was found, that type of pottery was found in the grave. If there's a 0, that type of pottery wasn't found in that grave. And what we do to get the information that we can interpret is we multiply this matrix, this grave pottery style matrix, we multiply it by its transpose. So remember, for a transpose, the row vectors become the columns, or the column vectors of the transpose matrix. So right here, row 1, which is 0, 0, 1, becomes column 0, 0, 1. The rows become the columns become the rows. So row 2 becomes column 2, so we get 1, 1, 0 in column 2. Row 3 becomes column 3, so we get 1, 0, 1, and row 4 becomes column 4. And because we interchanged rows and columns, now the columns represent the graves, grave 1, grave 2, grave 3, and grave 4. And the rows represent the pottery types, pottery type 1, pottery type 2, and pottery type 3. So the next step is to multiply those two matrices together. And this is a 4 by 3 multiplied by a 3 by 4. So the result of the product is going to be a 4 by 4 matrix. That's going to be 4 graves, grave 1, grave 2, grave 3, grave 4, by a grave 4 matrix. Grave 1, grave 2, grave 3, grave 4. And we encode in this matrix, by taking this product, information about the pottery types that were found in the graves. So remember, the first position, this is row 1, column 1. So we're really taking the dot product of row 1, which gives us information about grave 1, and we're dotting it with column 1, which also gives us information about grave 1. So in this case, when we take that dot product, we get 0 times 0 is 0, plus 0 times 0 is 0, plus 1 times 1 is 1, and we get a 1 here. And what we want to notice is that the diagonal is going to give us the relationship between the grave and itself. The diagonal really tells us the number of types of pottery that were found in that grave. So there was none of pottery type 1 times none of pottery type 1 is 0. None of pottery type 2 times none of pottery type 2 is 0. 1 of 3 times 1 of 3 is 1. There was one type of pottery found in grave 1. Now we do the row 2, column 2 position. This is going to give us information about the relationship between grave 1 and grave 2. And in particular, it's going to tell us how many common pottery types were found between those two graves. So grave 1 dotted with the grave 2 column, we get 0 times 1 is 0. We get a 0 there because grave 1 and grave 2 didn't share pottery type 1. 0. Anytime pottery isn't shared, we'll get a 0 in one of the two, at least one of the two entries. So we get a 0 saying nothing was in common. So we get 0 times 1 plus 0 times 1 plus 1 times 0 is 0. And what this tells us is that grave 1 had no pottery in common with grave 2. Notice this right here says grave 2 and grave 1. We want to know, what does grave 2 have in common with grave 1? Well, that isn't going to be any different than what grave 1 had in common with grave 2. We're going to wind up with a symmetric matrix. The entries are going to be symmetric across the diagonal. This lower part of the matrix doesn't give us information that the upper part of the matrix doesn't already give us. How many pottery types are shared between grave 1 and grave 2? If that's 0, then grave 2 and grave 1 will also share 0. We could see that by taking row 2, column 1 dot product. So row 2, column 1 dot product would be 1 times 0 plus 1 times 0 plus 0 times 1 is 0. So let's complete the first row. We do, this is the row 1, column 3. So we're doing grave 1 dotted with the grave 3 column. So grave 1 times grave 3 column, 0 times 1 plus 0 times 0 plus 1 times 1 adds up to 1. And that tells us that grave 1 and grave 3 have one type of pottery in common. And then we move to row 1, column 4. So grave 1 dotted with the grave 4 column, we get 0 times 0 plus 0 times 1 plus 1 times 0 is 0. Telling us that grave 1 and grave 1 and grave 4 have no common pottery types, which you could see by looking at the matrix. Neither of them have pottery type 1. Grave 1 doesn't have 2, even though grave 4 does. Grave 1 has pottery type 3, but grave 4 doesn't, so they have nothing in common. So then move down grave 2. We've already got this filled in. We'll do row 2, column 2. So this is grave 2, row dotted with the grave 2 column. So this number should tell us how many types of pottery were found in grave 2. So if I just count the grave 2 row, I see 1, 2. I'm expecting to get a 2 right here. But we could also get it by taking the dot product of row 2 with column 2. We get 1 times 1 plus 1 times 1 plus 0 times 1 adds up to 2. This one's row 2, column 3. So we're comparing grave 2 contents with grave 3 contents. So we get 1 times 1 is 1 plus 1 times 0 plus 0 times 1 all adds up to 1. And this tells us grave 2 and grave 3 had one type of pottery in common. You could actually see that if you compared the two rows, grave 2 and grave 3 actually share pottery type 1 in common. So this entry here is row 2 dotted with column 4. So we're working grave 2 versus grave 4. So we get 1 times 0 plus 1 times 1 plus 0 times 0 is 1. Grave 2 and grave 4 have one pottery type in common. This entry will be, how many pottery types does grave 3 have in common with grave 1? But we already know that because we calculated grave 1 in common with grave 3. So this 1 is going to pull down and be symmetric across the diagonal. This entry here will be, how many pottery types does grave 3 have in common with grave 2? But because I calculated the grave 2 row, I know grave 2 and grave 3 have 1 in common. Now I have grave 3 plus grave 3. This is the diagonal, so it will tell me how many pieces of pottery were found in grave 3. So that's going to be 1, 2. which we could also calculate with the dot product. This is the row 3, column 3 position, taking the dot product of the row vector. 1 with the column vector, grave 3, we get 1 times 1 is 1, plus 0 times 0 is still 1, plus 1 times 1 is 2, and there's the 2 that we put in. And this is going to be grave 3 and grave 4, which we need to calculate. So row 3 dotted with column 4, we get 1 times 0 plus 0 times 1 plus 1 times 0 is 0. Grave 3 and grave 4 have no pottery types in common. And if you compare the two rows, you can see that that is the truth. This is grave 4 with grave 1, which I could calculate with the dot product. Row 1, column 1, 0 times 0 plus 1 times 0 plus 0 times 1 is 0. Or I could recognize that grave 4 related to grave 1 has already been calculated right here. Grave 1 related to grave 4 is 0 types of pottery in common. Grave 4 related to grave 2 has already been calculated here. Grave 2 and grave 4 have 1 pottery type in common. Grave 4 and grave 3 goes here, but grave 3 and grave 4 have 0 types of pottery in common. And then grave 4 compared to itself should just be the number of pottery types found in grave 4, which is just 1, or row 4 dotted with column 4, 0 times 0 plus 1 times 1 plus 0 times 0 is 1. So to interpret, what we want to do is then use this matrix here to come up with a possible chronological ordering of the graves. We want to come up with a chronological ordering of the graves from what we think might be earliest to latest or latest to earliest. It turns out we can't get a direction from this, but we can relate chronologically the graves by analyzing the information in this upper corner above the main diagonal. So this here says that grave 1 and grave 2 have nothing in common. They're not related in time because they shared no common pottery types. But grave 1 and grave 3, because they share a common pottery type, might be related in time. So grave 1 appears to be related temporally to grave 3. We don't know if grave 1 came first and then grave 3, or if grave 3 came first and then grave 1. We just know that they're related in time. Grave 1, because it shares nothing in common with grave 4, isn't related in time to grave 4. Grave 2, however, is related temporally or in time to grave 3 because they share a common pottery type. So grave 2 is related to grave 3. And grave 2 is related to grave 4 because they also share a common pottery type. And if these numbers were bigger, that would mean that the relationship was stronger or closer in time, because these numbers also tell us how many shared pottery types. In this particular instance, no grave shared more than 1, but if this had a 3, that would tell you a stronger temporal relationship between the two graves. And then grave 3 isn't related to grave 4 in time. So we could interpret the bottom part of the matrix, but because the matrix is symmetric, we would get exactly the same information from the lower part of the matrix, the part below the main diagonal. And then this right here is enough to come up with a possible temporal ordering. So if we know, for example, if we just grab the center here, if we know grave 2 is related to grave 3, and then we look at the other relationships, we see nowhere is grave 3 related temporally to grave 4. So I know I can't attach grave 4 to grave 3, but grave 4 is also related to grave 2, so it's got to be on the other side in time. Whereas we look at this as ascending time. Ascending time, grave 4 is related to grave 2, but it's not related to grave 3. And then grave 2, so is that all the information we have? Grave 1, 2, 3, 4. Grave 1 is related to grave 3. Right here, grave 1 is related to grave 3, but we see grave 1 isn't related to grave 2 or 4. So grave 1 is going to attach to grave 3. So here's one possible chronological ordering. Grave 4 is the youngest, grave 2 is the next, grave 3 is the third newest and grave 1 is the newest grave, or because there's no time information here, the relationship may go the other way. It may go grave 1 is the oldest grave, grave 3 is the next oldest grave, grave 2 is the next oldest grave, and grave 4 might be the newest grave of all. We would need additional information to know which direction the chronology went. Does it go this way or this way? We would need to do some other form of dating technique to come up with the ordering on it.